Welcome back to Coding Intuition. Today we are going to understand union find algorithm, and which is also called disjoint set. So let's just get started with this algorithm. So in this algorithm, we can say we are given some kind of sets, and we need to find out if these particular two elements exist in a similar set or not. For example, let us see this. Let us say we have given this graph. Let us understand it by an example of graph in this case, and it can also be done on sets or anything. Okay, so in this case, let us say we have this graph, and we have disjoint graph in this case. So it is another graph we have, and we need to find out if 2 or 1 exist in same graph or not, or we need to find out if this 4 and this 2 exist in same graph or not. So that we can do by using union find algorithm. So in union find algorithm, basically we are will be given of a set of, let us say, numbers, and we need to find out if these two elements exist in a same set or not. So that thing we can do through union find algorithm. So let us understand it more better by going through an example. So now let us try to understand union find by an example. So as we can see here in this example, let us say we have to union these values together and form a set after uniting these values, and then we will try to find out if these elements below here exist inside the same set or not. So let us first do the union. So let us say first of all we unite 1, 0 and 1, and but in this case what we will be doing is whenever we assign a value to its parent, basically we will at that index we will say its parent is that number. So basically the parent of 1 becomes 0, and now again we have 0 comma 2, so we will say the parent of 2 is also 0. We need to decide any one parent among them. We can decide it to be 1 or 0, and that's it. So we can decide any of them to be a parent. Okay, so again let us say we have decided 0 to the parent, and in this case again let us decide 1 to be the parent. We have connected 1 and 3 here. So here let us say we have connected it like this and this. So that's how we made our one set here, and we will only be using this array to determine everything inside our solution. So that array will be our set, and array will be used to find something. So let us just connect all other values and then see how we can proceed on this. So let us connect 4 and 8, and in next time we are connecting 5 and 6, and then we are connecting 5 and 7, and as we connect them we will update this array as well to their parents. So the parent of 4 is, let's say, 4, and the parent of 8 is 4. So basically the root node will have the same value as it is. So basically this will determine if this is a root node or not. In this case we have decided 0 to be our root node. In this case we have decided 4 to be our root node. Okay, so now let us just connect all other values as well. Let us say in this case let us say 5 is our root node, and so 5 will remain same, and the parent of 6 will become 5, and the parent of 7 will become 5 again, and 9 we have here. 9 is just alone here, so that is another disjoint set. Okay, so now we have formed the union. Now let us try to find out these values if they are connected or not. So let us first try to find out if 3 and 0 are connected or not. So what we will be doing to find out is that we will be trying to see what is the parent of 3. The parent of 3 is 1. We have checked the parent of 3 is 1. Okay, the parent of 3 is 1. Now we will check until and unless our index value and our value inside our array becomes same, we will keep checking this. Now we will go to 1 and ask it, what is your parent? So we will it will say my parent is 0. So the parent of 1 becomes 0. Now we will move to 0, and the parent of 0 is 0. That means we have moved to our root node. Now we know that the root node of uh, uh, value 3 is 0, and now let us check the root node of value 0. The root node of value 0 will be 0 by this array again, or we can say we are going to find 1 and 3. In that case also what we will be doing is we will going to 1, from 1 we will be saying its parent is 0, and 0's parent is 0, which means it is a root node. So both of them has a parent which is 0. So in that case we will say yes, they exist inside the same set. Okay, that's how the union find algorithm basically works. Okay, similarly let us do with 1 and 5. So 1 and 5, the parent of 1 is 0, and again it is 0. So the parent the root node for the 0 is 1 is 0, and the root node for 5 is 5. So in this case we have seen that the root node for both of them is not equal. That's why they don't exist in the same set. Okay, and this exists in the same set, and this also don't exist in the same set, because we will go to 7 and ask 7 what is your parent. 7's parent is 5, and we will ask 5 what is your parent is 5. So parent of the 7 is 5, and again we will go to 8. We will ask it what is your parent. Your parent is 4. So and the parent of 4 is 4 again. So basically here we have also checked that the parent of 8 is 4, and they don't exist in the same time because their root value is not similar. So that is what we need to do in union find algorithm. So now let us try to understand how we will be implementing this inside the code. So first of all, let's understand the quick find algorithm, and then we will try to understand the quick union algorithm. In this algorithm, our find operation will be faster. So what we will be doing is whenever we decide to union two numbers, let us say we decide to union 1 and 3, and this is what we have already done in the previous example, that we have just assigned each index the value of its parent. So value of 2 is where 2's parents is 0 and 3's parents is 1, as in this example, and 5 parents are 2 and 6 parents are 2. So what we will be doing is we will iterate over the array whenever we want to combine two elements. For example, we want to combine 1 and 3. Okay, so what we will be doing is we will iterate over the array and try to find out the x. We will find out the x at this index 3. Okay, basically, let us say we have two elements x and y. Our x is 1 and y is 3. We will try to find out y. Wherever we find out the y, we will say that the root of this person is this node. Okay, so basically we will iterate over all over the array, and every time, let us say in the starting, when nothing was there, we have this. So we have this x and y. We have gone to union and said find one in the array. We have found one in the array. Okay, and then we will say your root is 0. Similarly, we will do for all of them. Now for this, when we come to this, it will get the root of 1. So root of 1 is 0. Again, basically what we are getting at the end of this algorithm is whatever is the main root of this our current set, or you can say our current graph. Okay, if let us say in this example we will just set all of them to 0 because all of them has a common root. But let us say we have a separate uh, we have distant graph in this case. So if we have a distant graph, and so in that case our last two values would not be 0. In that case, it will be the value of this it will be the root of this distant graph. So what we are actually doing is we are just initializing the roots of our nodes inside our array rather than our parents of our nodes. Earlier we were doing it by the parents. In this case we are doing it by the root nodes. So if this is a different separate entry, then in that case we will assign it parents to 2. Okay, now let us move to the code and understand this algorithm much better. So now for doing this, we have created a class called union find. So in this union find class, as we have seen, firstly we will assign all of the root values to their values only. So basically 0 is the root of 0, 1 is the root of 0. First of all, we will do this inside our constructor, and we have created a class and we have created an array called root, and we will be using that throughout our algorithm. So now let us first understand find function. In find function, as we have seen in the example, that we just need to return the current root. So basically, the root of current element will be stored. For example, let us say we have 2. So the root of 2 in that example is 0. So we will just say that return the root of current element. So current root of current element will be stored inside that. And in this case, the time complexity of this would be O of 1. And now when we will move to a union set, we will try to firstly we will see what is the root of x, what is the root of y. So first of all, let us say no value is inside the set, and we are going to connect to 0 and 1. So the root x will be 0 and root y will be 1. And if root x and root y are not equal, basically we are already not at root. If we are not at root, we will say we will iterate over the array, we will iterate over the complete array and try to find out the root y value. And as soon as we find out the value of root y, we will say that its parent is root of x. Basically, we have given two values, and we have said that one of them is our parent. Wherever we see root y basically inside our array, so we are saying that, for example, we are saying that whosoever has parent 1, as we have seen on the whiteboard right now, that there are 2 and 3 has the parent 1. So we have assigned both of the ones to root x, basically to 0, and the value of their parent becomes 0. So the time complexity of this would be O of n in this case. So this is the approach we can take to solve this question. Now there is a way in which we can reduce the time complexity of this union set function to less than O of n. So let us just try to understand that by going on. So now in quick union algorithm, what we will be doing is we will be assigning the values of root again to our nodes, but in this case we will iterate it through our tree. Let me show you how we will be doing that. So in the quick find case, we were iterating all over the array in our union function, and trying to find out what will be the node of will be the root of every node. For example, this 3, the root of this 3 will be 0, and we are iterating all over the array to find out the its root node. But in this case, what we will be doing is we will be saying the root node of 3 is the parent node of 3 is 1, and the parent node of 1 is 0, which is our actual root. So we will go like this in this algorithm inside our basically inside our find function, and assign this value to 0 again. And you will say, how is this different from quick find algorithm? Let me just show you by another example. For example, these two things are connected. Now the root of the 4 becomes 0, but in this case we are not iterating on the array to decide what is the root of 4. We will go like this. We will first of all we will say the parent of 4 is 0. Now we have changed the parent change the parent of 4 to 0, and uh, as we have changed the parent of 4 to 0, now we will check it like this. We will say, and we will come to 5 and say this 5 parent of 5 is 4, and the parent of 4 is 0. So now what we need to do is we need to just say that the root node for 5 and 6 is also 0. So we will do that here, to be 0 here as well, because in this case these are connected. like this. So that is what we will be doing in quick union algorithm. So let us try to understand it by code. Now, as we can see inside the code here, that the only difference in this algorithm is that is the find function. In the find function earlier, we are just returning the value, whatever the value is inside the root. But in this case, we are saying x, what is your root? Okay, until the root is equal to its value, we are not at the first root of the graph. So we are asking x, what is your parent? We are going to its parents until we reach the root, and we will find the root in that way. And in union set, we will just find out the both of the roots, and if those are equal, we are at root. That means, and if we are not at root, we will assign the value of y to the root. Basically, this means that we are assigning our current value to its original root. Whatever we found out here, we have found out the root of x here and the root of y here. Now we are saying if we want to connect this two values to each other, then their root will become same. That's it. That is what we are doing here. We are saying that their root will have to become same. If we want to connect these two values in one graph, their root will be same. So that is what we are doing in this line. And the connected function is same as before. We just find x and find y. The root of both of these values are same, and then we can say that they are in same graph. So basically, all things come down to the root in both of these algorithms. But the main difference is that we are trying to find out the root of our any node inside the find in this algorithm, and in above algorithm we are trying to find out the root by iterating all over the array in union set, and then find we are not doing that. Okay, so this is a basic difference between these two algorithms. So now in this case, the watch case complexity of this algorithm, this will be of n, because and that will be in the case where we have a tree which is a straight line. I will show you that on the whiteboard after this. So we can say that in this case, the coin complexity would be less than often. It will equal to be often in the worst case. But if we have a proper tree, if we have a balanced tree, in that case, it will be the height of tree actually. So that would be reduce our time complexity. So that is why this algorithm is a little bit better. Now for the worst case, this time complexity is of n. So now let us try and see if we can improve this algorithm a little bit more or not. So now let's first understand why time complexity would be less than n in the last algorithm. The time complexity would be less than n because let us say we have a graph in which everything is in one line like this. So in that case, the time complexity will obviously be O of n. But if we start to make a tree like this, then it will reduce to the height of our tree. So that is why the time complexity will be obviously less than O of n. Okay. So now let us try to understand how we can optimize this algorithm even more. So let us assume that we need to connect these two graphs here. So let us say we need to connect this 5 and 0 together. So we have two ways of doing that. We can either decide our 0 to be root and assign all the values in 5 and 6 to it. To say that the 5 and 6, your new root is now 0. And another thing we can do is we can say 5, you are the new root, and uh, say all the elements in this graph that your new root is 5. As we can see here, in this case, we have made 5 our root, and in this case we have made 0 our root. Okay, so now as we can see, while deciding to connect the two different graphs, we need to be cautious, because as we have seen in the previous algorithm, as much as the height of tree will be more will be a time complexity. So let us see what is our height in this case. So as we can see here, our height in this case is 1 2 3 4. Okay, the height of our tree is 4, but in this case the height of the tree has increased. It is 1 2 3 4 5. It is 5 in this case, and for this tree it is again 4. So if we connect, so basically what I'm trying to say, if we connect our 0 to this 5, in that case the time complexity will be less, because the height of our this tree would be less than 5. That is in the case if we make 5 our root element. So we need to consider one thing, that whatever is the height of our current, basically we will say it the rank, whatever is the height of our current tree, and we want to merge it with another tree, whosoever has the greater height or the greater elements in them with connected with one another, making the greater chain, that will be assigned as the root of the tree, because that will not contribute in increasing the height. If we make something root which is less than this, for example, in this case it is 2, it will increase the height because it will increase one more level inside our tree. But in this case, as our height is 4, so this 2 height will be indulged inside this already existing graph. Okay, so that's how we can optimize this algorithm furthermore, by considering the ranks of our each and every element, basically a height of each and every element, and whosoever has a great height, we will decide to make that root rather than making other one root. Okay, so let us just move to code and understand it much. So in union find by rank, what we will be doing is we will consider another array for the rank, and the rank will be basically the height of each node, and we will initialize it to 0 for each and every node. And in the find, we will be doing the same thing. We will be going to the parent of each node until we find the root node. And here we will be doing the same thing as we have done inside the our previous algorithm. But here, rather than directly assigning any of them to be the root, we will decide it by their rank, that who should be a root, who will be a root. That will reduce the height of completely all over a tree. So what we will be doing, if our x is greater, so we will say x, you are the root of y. And if our y is greater, we will say y, you are the root of x. And if this is not true, we will say just increment the rank of this current element, as we are going downside more down, so we will increase more away from the root, so we will increase the rank of that particular thing. So that is the difference between these algorithms. Now we can do one more optimization inside our find function. So let us try to understand what is that optimization is. Now for doing one last optimization inside our code, we need to do one thing. So as we know, inside our find, we are running a while loop to find out basically the parents of the parent, and finally to find out the root. But here we can say that one will ask 0, that you are my parent. The parent of 1 is 0. So okay, and the root for 1 is also 0. So now 2 will ask 1 that who is your root. 1 will tell 2 my root is 0. Now 3 will ask 2 who is your root. Here again we will tell it is 0. So rather than just finding out our root by going on while loop like this and this and this, we can just find it through whatever we have stored inside our array, and just tell this for it is kind of like DP thing, dynamic programming thing, that we just store in we have already stored inside this array that 3's root is 0, and we don't need to go to this and this every time, because we can just get our root through this only. So let us just quickly understand this simple concept through code. Now finally, only one change we have done inside our algorithm, that is this find function. This find function, we are saying if you are root, just return x, that you are root. If you are not root, you try to find out your parent, go find out your parent, do the same thing, but I will remember whatever as your parent is. So that's how using recursion we will be doing it. It is also called path compression. We are just compressing down the path and to find out the root immediately. So this is a union find algorithm. This is a completely optimized version of it. I will attach all the version of it in the pinned command. In the pinned command, you can find the complete code there. So thank you so much for watching. Bye bye.